checking problem 5 on the practice exam. So this one is asking us to determine the radius of convergence of the power series, only the radius. So we do that with the ratio test. So we'll find the limit as n goes to infinity of the n plus 1th term, which will give us n plus 3 x to the power of n plus 1 over n plus 1 multiplied by the reciprocal of the nth term, n over n plus 2 x to the... Okay, so let's see, we can write this as, well, x to the n plus 1 over x to the n. Subtract these n plus 1 minus n just leaves you with x. Oh, and we're forgetting absolute value on this thing. That absolute value is pretty much essential here because x is a variable and it could be, could potentially be negative. So again, when we cancel this with that, n plus 1 minus n just leaves us with x, and that's gone too. So all we have left up here is x. That's the only thing that could potentially be negative here, so we need to sort of bring those absolute value bars around it. That does not now depend on n, so we can bring it outside of the limit. And then what's left? N plus 3 times n, that's going to give us n squared plus 3n over, and then if we multiply this out, we get n squared plus 3n plus 2. This limit, n squared over n squared, both have coefficients of 1, so that whole limit is just 1. That tells us that this overall limit is absolute value of x. Since we've done the ratio test here, and this is what we got, the ratio test requires, for convergence, this quantity to be less than 1. So for convergence, that's what we need to have happen. We would want to see absolute value of x be less than 1. Since there's no coefficient here to solve this for absolute value of x, this is really all we need. This value that we get right here, that is the radius of convergence right there. Since that's all that's being asked for in this question, that's it. The radius of convergence is 1. For part B, we've got this series here, and we'll do the ratio test again. So we'll take the limit of the n plus 1th term, so that'll give us 2 n plus 1 whole thing factorial x the n plus 1 over n plus 1 factorial whole thing squared multiplied by reciprocal of the nth term. So it's going to look like this. Put the absolute value bars around this whole thing. Okay, then let's go ahead and again, same thing's going to happen here as the last one, n plus 1, x to the n plus 1, x to the n. That's basically just going to cancel all of that. We're just going to be left with x there. So let's go ahead and bring that out, just like before. And then what are we going to have left here? This is going to be 2n plus 2 factorial in the numerator, and then we've still got that n factorial squared. And what else do we have? We've got this, n plus 1 factorial squared. And we've got the 2n factorial. Okay, so let's think about how we would rewrite this to cancel some of this stuff. So let's write this as 2n plus 2. Let's get the absolute value here. We'll get 2n plus 2. Let's write that as 2n plus 2 times 2n plus 1 times 2n factorial. N plus this n factorial squared, we'll just leave that alone. N factorial squared. That one, let's rewrite that as n plus 1 times n factorial. And that's still squared. And we'll just write that 2n factorial. Leave that one alone. Okay, so let's see what happens here. This and that are going to cancel. Now notice that when I square this, both things have to be squared, so the n plus 1 gets squared and so does the n factorial. So that n factorial, since it is squared, it's going to cancel with this one here. Okay, and then what does that leave us with? So we'll have, still have that x out here. and then we'll have this in the numerator, so we'll get 4n squared plus 6n plus 2 in the numerator. And again, that n factorial squared cancels there. The left is with that, but it is also squared. So if I square that, I get n squared plus 2n plus 1. Comparing degrees, they are the same. And so the ratio of the leading coefficients is 4 over 1. So the limit is 4 in this case. And including the absolute value of x there, we've got that for our limit. And then for convergence, what has to happen, we need that quantity, the limit that we just got for absolute value of x, we need that to be less than 1. So to solve for absolute value of x here, I would divide both sides by 4, so I get absolute value of x must be less than 1/4. And this number here, again, once you reach this point where you've just got absolute value of x minus something or plus something, then this quantity right here is the radius of convergence. And so in this case, the radius of convergence is 1/4. And again, this doesn't ask for interval, just radius, so we're done.